about some concepts on finding first and follow. Should we take few more things on that, or is it okay to you? On the chat if you want to write. So I think anything from your side on the yesterday's concept? Any questions? Any doubts which you have? Okay, fine. So now let us continue. Like I have discussed some concepts on finding first and follow with you. Okay. So if you want to prove any grammar as LL1, there is a simple technique which you should use. Let me just share the writing board with you. So many times you get a question in GATE wherein they ask you that prove that given grammar is LL1. Okay. And then the grammar has certain production rules like S tends to something maybe in the form of like production rule CC, and C tends to something like this. Okay. So what you need to do here is if you want to prove that given grammar is LL1 or not, okay, then simply take each and every production rule, okay, each and every production rule, and for every production rule find the first, okay, and check whether the intersection of the first information is equal to 5. So for example, here if I say first of capital S is nothing but first of C, okay, and if I say what is first of C, then first of C is nothing but it is C comma D, okay. So the intersection will be phi, and then the grammar can be considered as LL1, okay. So every time you need not solve the entire problem, you can just find the first and check whether the grammar is LL1 or not. Okay. There are there is another type of parser which we yesterday just touched upon, that is also very efficient and accurate parser, that is called as bottom up parsing, and it is also represented as LR parser. Okay. So LR parser has various versions. You can take it as LR0, you can take it as LR1, then you can take it as SLR. This is simple as LR, canonical LR, and look ahead LR. So I would suggest you to please check what are the differences between these types of parsers. Okay. So whenever you try to find out something related to LR or something on LR parser, you will consider the first information, and then this first information will be augmented on the production rules, okay, and they will basically make the parsing process more faster, okay. So that is the idea for LR parser. Okay. Uh, Let me start with some questions on syntax analysis from the gate perspective. Uh, I will be discussing these questions, which are slightly interesting, and also they are quite repeated number of times in the gate papers. Okay, so let me share you another screen. Right. So this is the first question, which is coming up on the screen. Assume that SLR stands for simple LR, parser for a grammar. Okay, and it has N1 states. That is, SLR parser has N1 state, and LALR parser for the same grammar has N2 states. Okay, then the relationship between N1 and N2. So SLR uh, is, again, we can say that it is simple LR, and LALR is nothing but look ahead LR. Okay, so in that case, the number of states in the two parsers, because see, LALR is optimized. Okay, LALR is optimized, and SLR is not optimized. So normally you will find that the number of states uh, in SLR and number of state in LALR, okay, they are necessarily equal. Okay, so the answer for this question is option B, because although it is optimized, but SLR is basically one version of LALR, so number of states will be equal. Then this is one more question which is there repeated many times in the gate paper. Let me come to that question. So let me do this. So every question in the gate will have four choices. Okay. Now the question is, the grammar is given. Okay, this is in 2005. Grammar is given, and then for this grammar, what you need to find is, for a sentence n plus n cross n, the handle in the right sentinel form of the reduction R. Okay, so what are the handles? Handle is basically that entity which will be used for the replacement. Okay, handle is that entity which will be used for the replacement, and it will be always treated as rightmost derivation. Okay, RMD is rightmost derivation. Okay, so what you need to do is to predict or to find out which what are the handles. Okay, so handles will be basically the production rule which are present in the right hand side of the grammar. Okay, so hence you can check the choices, and if in the choices you find that the right hand side of the production rules are present, look at this. The production rule is E plus n, E multiplied by n, and n. Okay, so normally the handle is that entity which will allow you to replace this part of the string with this particular component. Okay, this part of the string with this particular component, and this part of the string with this particular component, that will be called as what? Handle. So if I say there are four choices A, B, C, D on the chat window, can you write which choice is correct? Write your answers on the chat window. Which choice will be correct from the explanation? The explanation is handle will be that part of the production rule which will allow you to do the replacement. Okay, which will allow you to do the replacement. So if you see this entity, you can replace it by E. So any answer, anybody, write on the chat window. In which of the option A, B, C, D you see that there is a possibility of replacing the available choice with the rule E. Anyone? No answer on the chat. Speak or write something on the chat. Am I audible?
Yes, sir.
Are you able to see the screen that consider grammar CS 2005? This screen is visible to all?
Yes, sir.
Yes, yes. So देखिए ना अभी इसमें what where do you see in the first rule, do you see that after and there is what is written E plus N cross N, whether E plus N cross N is there in the right hand side? No. E plus E cross N is also not there. N plus N cross N is also not there. So what is the choice? Simple choice is yes, E, right? So this way you can always. I don't know whether you are aware about all this, but if you want, I can teach you all this. So should I teach it first and then should we do the question answering? What
So
is
we are unable to comment.
sorry?
So
Sorry?
we are unable to comment means when we are sending the comment, it is saying failed to send. Tap to resend or delete. Saying
Ajay, you're not able to write on the chat?
yes, sir. We are not able to write.
Okay. Everybody is not. No, no. I think we got some. I got some chat from Farhan. You can just put some message on the chat. Hello, message. Everyone. See if you can write. So let everyone to send messages. I'm allowing everyone to send message. Check now. Bushara, can you check it again?
Yes, sir. Now it is okay.
Yeah. Okay. Uh, can you tell me like should I take the question answers directly or should I teach like I did in the two classes? What is your preference? Do you know all these things already or I am told that I should take some gate questions. So but then should I teach or should I take questions? Please give me your feedback. Because if I teach, then we can cover some topics, but then questions like yesterday, we could not cover some questions or we could only cover very few questions. So tell me quickly, what is your opinion? So you'll have to let me know, then only we will be able to do the justice to all this. So tell me something on that quickly. Okay, I will continue with the questions for the today's class. Then in between, you let me know your inputs. Okay, but before that, it will be good if you can tell me that yes, I know parsing or I don't know parsing. So this is one more question which generally comes a lot of times. Let me come to that question. So this is another question. So if there is a LALR parser, okay, and that parser is basically uh, having a conflict called as shift reduce conflict, then uh, an LALR parser for the grammar G can have SR conflict if and only if. Okay. So, so LALR is constructed based on, let me make it clear that LALR is constructed using LR1. Okay. So if in LR1 there is a conflict called a shift reduce conflict, then in LALR also there will be a shift reduce conflict. So do remember that LALR is an extension of LR1 parser. Okay, one more same lines. Let me put it for you on the slide. So sometimes they give you match the followings like this. There is a good number of times you get group 1 and group 2. Okay. So match all items in group 1 with correct option from those in group 2. This is from 2009. Okay. So there is a regular expression, push down automata, data flow analysis, and register allocation. Okay. So just remember that registers are allocated at the time of code generation. So this S and 2 will be connected. Data flow analysis you do for code optimization. Okay, right? And regular expressions you used in lexical analysis, and push down automata you make use in syntax analysis. So you need to you if you take some idea, if you have like register allocation where it is done. So code generation, data flow analysis, code optimization, regular expression, lexical analysis, and push down automata is syntax analysis. Okay. So the choice for this, you will get some choices like this. Okay. Under this, you will get some choices like this. Okay. A, B, C, D. And you need to write down which choice is correct. Okay. So according to this, the choice which is correct is, suppose I say regular expression, it is 3, push down automata, it is 1, okay, right, correct. And data flow analysis for what? Code optimization, and register allocation for code generation. So choice B is correct, okay. So this way you get questions on match the following, okay. Then most of the times you are required to also check whether the grammar is LL1 or not, or LL1 but not LR1, okay, and so on. Okay, so so whenever a grammar is LL1, okay, it will be also LR1. If your grammar is LL1, okay, then the grammar will be LR1 also. Okay. So let me take one more question on this. This is from the recent paper 2010. So this is the choice. Grammar S derives to A, S, A, and B, S, and C. So whether the grammar is LL1 but not LR1, LR1 but not LR0 but not LR1. Okay, both LL1 and LR1 and neither LL1 nor LR1. So what you need to do in such questions is you just try to prove whether this particular grammar is LL1 or not. If this particular grammar is LL1, then you can pick up some choices, and because you cannot directly jump to constructing the parser for a given grammar in the time frame available to you to solve this question. Okay, so I told you that explanation will be find the first of every production. So first of ASA is A, first of BS is B, and first of C is C. Okay. And if you take the intersection of all these three, it is null. Hence the grammar is LL1. Okay. So if the grammar is LL1, then you ensure that the grammar will be also LR1. So the choice number C is correct, or choice 3 is correct, that both it is LL1 and LR1. So these are simple tricks which you need to basically check, that if the given grammar is there, they may ask you whether it is LL1 in combination with LR1. So, so proving the grammar LL1 is very simple. What you need to do is to take the production rule, and for every production rule find the first, just like we did here. Let me write for you also. If you want, I can write first of AS A is equal to A, small a, then first of B S is equal to B, and first of small c is equal to C. And you can find that intersection of all this, intersection of first of ASA followed by, so the intersection sign is reverse U. Okay, so I write intersection here. Then again first of BS, and again intersection what? Intersection first of C. So if all these things, if the intersection of all these things is equal to null, then the grammar is treated as what? Grammar is treated as LL1. Okay. And if the grammar is LL1, then definitely it will be LR1. This is a simple trick to solve such questions, and you get quickly, you get 2 marks here. Okay. So, so remember that whenever you are solving the questions related to grammar, you should be able to solve. You should be able to solve the first and follow. Very important that you should know how to calculate first and follow. Okay. Sometimes the match the following is also based on the application. Let me take one more example on that. So this is one more. Uh, Here you are having list 1 and list 2, and this is from 2015. So lexical analysis, parsing, register allocation, and expression evaluation. Okay. So remember that there will be some hint like, okay, so how do you do expression evaluation? So there are three types of method: in order, pre-order, post-order. Okay, right? So in order, pre-order, post-order. ABCD is the code. So D needs to be connected with 3. So now you have two choices here. One is this and one is this, right? Now let us try to do some more things, right? So basically there is a application of register allocation. Register allocation is used for graph coloring. Okay, so C is used with 1. Now look at this, how quickly you resolve this. This is D3, C1, and then even if you don't know about A and B, you can come to this choice, that is 2413. Okay, so what is 2? It is parsing. Parsing will be, just we have seen there is a production tree, and lexical analysis is nothing but it is DFA optimization. So nowadays there are two sets, and in set two, you have the questions on computer science. Okay, so this is one more very interesting question which is there in good number of papers, wherein you are required to talk about how to do the evaluation. Okay. Then there are a few questions like sometimes you will find a very lengthy question, and then that lengthy question needs to be resolved. Okay. So that lengthy question needs to be resolved. So let me come to some questions like this. This is one more question. Uh, so there was one suggestion from Nuzat that she's asking that I should teach first. Okay, so let me take this. How many of you want that I should teach and then we should take the, so because I am only given another 3 more hours to cover this whole all. Okay, all concepts of compiler design. So I don't know how much teaching will be possible. Basically, taking the questions, solving them, so you understand. But then write on the chat first that you want I should teach. Then I can teach also, not an issue, because I can teach anything on computer science. So let me have your opinion on that. Ritik is also saying teach. Harsh, okay. Let me have some opinion more. Because it should not be like this key, you know all this, and I'm unnecessarily teaching you all this. So that should not happen. Bushara, don't leave. I'm teaching, not an issue. 5 students are saying that teach out of 16. So others' opinion is also very important. If you say not, don't teach, then I can take the questions. But if you say teach, then I can teach also. Please put your opinion so that it will be very useful for me to justify my time spent with you. Okay, I think good number people wants I should teach. Good. So that's helpful for me, not an issue. Uh, so what I think what we can do is in this 6 hours we can cover something on LR and LR0 or LR1 we can cover LR, then LR we can also cover LR SLR, and we can cover LALR. Okay, and then I will touch something on code optimization. And I will speak to your professor if they want, if they allow. I will teach for another 2-3 hours more. Okay, so let us because I should keep your interest live. Okay, otherwise there is no meaning in this all. Okay, I just want you to be present with some interest, which I have already seen in the first 2 classes. So I don't want to lose that and do something in which you are not interested. Okay. So let us go further. Good. Thank you. Let us start with the teaching idea. Let me prepare some slides and then I can start teaching you. Just a minute. Huh? Okay. So thank you for your opinion. I'm going to maybe so so yesterday we discussed first follow. I think that is clear to you, or if it is not clear, this idea will make the things more clear. If you are finding first follow, generally we take this rule: s derives to x y z. So we can take first of x, first of s, not s, first of s is equal to first of x y z. Okay, and this is equal to first of x. Okay, and if this first of x contains epsilon, then we make the move further. Okay, so if it is containing epsilon, then we write first of capital S is equal to first of x minus epsilon union first of yz. Okay, and then this first of yz needs to be calculated. Similarly, we can compute follow also. Okay, so follow will be computed for non-terminals which are present on the right hand side of the production rule. Okay, and once we see something like this, let us assume that we have a rule s tends to ax, y, and z. Then we have to compute follow of x because it is in the right hand side. That will be equal to first of yz. So first of yz will be calculated using the first rule directly. First of yz will be equal to, it will be nothing but it will be equal to first of y. And if first of y is containing epsilon, then you write first of yz is equal to first of y minus epsilon union first of z. And very important is follow will never have epsilon. Okay. So what will happen if there is a rule s derives to ax? There is nothing here. So then we can write follow of x is equal to, we do a circular linked list here, follow of s, and by default follow of s is equal to dollar. Okay. So generally, as long as you have epsilon, you will. So now, if this also has epsilon, then you can write here. Finally, you can write follow of x will be nothing but what? uh, First of yz, and if first of yz contains epsilon, it will be written as, it will be equal to first of yz minus epsilon union. Now you apply a follow of s rule. Okay, so should I show some more examples on this, solved examples to you so that you understand from the slide, or this is okay? सो क्विकली रिस्पॉन्ड, आप थोड़ा जल्दी जल्दी रिस्पॉन्ड करिए चैट विंडो पे कि भाई सॉल्व एग्जांपल बताइए, तो मैं सॉल्व एग्जांपल दिखाता हूँ आपको, नहीं तो फिर आगे चलते हैं, बताइए फटाफट. ओके, वन मोर, राइट, सो गुड. Anybody else? One more example would you like to see, or it is okay to you? Okay, good. So let me share one screen with you, so that it is good to understand, right? All the times we should not be in the waiting state for somebody. Good. So let us stop this, take another screen, and take one solved example. तो बताइए, अच्छा पढ़िए तो आपको सब समझ में भी आ जाएगा. So now here there is one more example. Okay, right? Sometimes they give you epsilon first and then this. Okay, here there is a left recursion, so you are eliminating the left recursion because this e and this e is same. Okay, so this is a left recursion problem. Now So what we are doing is we have removed the left recursion. Now how to find the first? So first is very simple. This is first of B. First of B is B epsilon. Now since first of B contains epsilon, you move further. Why do you move further? Is it clear? First of B is containing. So first of A is nothing but first of BCC union GDB. That is first of B union G. First of B is this union this. Okay. So now first of A is nothing but B epsilon minus epsilon union first of CC. Why we did this rule? Is it clear? We are doing this rule because this B first is containing epsilon. So we'll have to move further. Now for that we'll have to find first of C. What is first of C is small c and first of D. And what is first of D is epsilon and D. So again we move further. Okay. And in this way we calculate the first. So as long as there is a possibility of removing epsilon, you continue removing the epsilon. Otherwise, you decide that epsilon will remain there. Okay. So here, if you look at first of E is C, no problem. First of E dash is A epsilon, no problem. First of D is D epsilon, no problem. First of B is B epsilon, no problem. But for this grammar, the problem exists with first of A. Okay. So so let me take this grammar on the slide and solve it for you so that you will be able to understand how first is computed. Okay. And then we can take follow also. I'm just putting it on the slide for you and then we can solve it. Okay. This one and followed by these two. Yes. And I will stop this sharing and I will take the slide sharing. Okay. So now check whether my slide is visible. Let me share it. Then I can write on this slide. Okay. So problem does not exist with any of the rule except the rule of A. Okay. So look at this. What is, if I compute first of B, it is very simple. First of B is nothing but first is this one, B and epsilon. Okay. First of C. So if it is not directly computed, you can compute first of D also. So it is D and epsilon. Okay. Right. And first of E is simple. So you can compute all the first in simplified manner. It is C. And then first of E dash is nothing but A epsilon. Okay. Now what we want to do is to compute first of, let us say compute first of C. So look at this. This is interesting. First of capital C will be equal to first of what? Capital DAB union first of small ca. So there is no problem here, but the problem exists here. So first of capital DAB will be equal to first of D, okay? And that first of D is already computed here. That is D epsilon. Now, since it contains epsilon, you will have to write first of DAB will be equal to first of D minus epsilon union what? First of small ab. And now this will be d epsilon minus epsilon union. This first of ab will be simply a. So this epsilon epsilon gets cancelled and you get ad. Okay, this a and this d, right? And one c. So you can very easily write first of c will be equal to what? Yes, are you getting this now,
Yes, sir.
Harshad? First of C will be equal to what? First of C
A,
will
B,
be
C.
A, D, and C. Okay. Right, good. The problem still exists with now first of A. So let us try to compute what is first of A. I will write here. First of capital A is equal to. So there is no problem if the rules start with terminal symbol, but if it starts with non-terminal, then it creates the problem. So first of BCC, what is first of BCC? It is equal to first of B, and first of B is what? It is equal to already given B epsilon. So since it contains epsilon, we move further. So first of BCC will be, so small c, not capital C here, small c will be equal to first of B minus epsilon union first of what? Capital C, small c. Okay, so let me remove this for the time being. Now, first of B is already there. It is B epsilon, okay, minus epsilon, okay, union. What is first of CC? So, first of CC is
Capital
first of
C.
C. And what is first of C? Yes, good. You have ADC. Yes. So, now this epsilon gets cancelled and it is A, B, C, D. Okay. And what is coming from this end? It is G. So now you have A, B, C, D followed by G. Simple. Now we are done with everything, and now we can compute what? After this, we can compute what? Follow. Got it?
Yes, sir.
Yes, good. So once we are done with first, we will compute the follow. And what is follow here? Let me show you the first. So look at this A, B, C, D, G. Okay, I will stop sharing this. I will share the Word file now. So, yes, now people are joining again because I'm teaching, I think. Yeah, that's good. If I can teach, not an issue. Don't worry. You let me know. We can also have some more. Uh, we will restrict to some topics, but we'll do it very correctly. Okay. So now it is fine. We have this first information, and now we can try the follow. So since A, so there can be any start symbol here. Here can it can be S or A or B. So since A is the start symbol, we write follow of A as dollar. That is a default rule. Now we consider the first rule. A derives to capital B, uh, capital C and C. So when we are talking about capital B, follow of capital B is first of CC. And that is first of C. Already done. ADC, not an issue. Follow of C is C, not an issue because it's a non-terminal symbol. Let us move further. A derives to ADB. First, we'll have to find follow of D. Follow of D is first of B, and that is ABD. No problem. Okay. Right. What is first of B? Uh, First of B is what? First of B is B epsilon. Okay. Right. So B epsilon will create the problem because there is epsilon. Right. So in this way, we when we are calculating follow of D, we'll calculate first of B. First of B is already calculated here. Looking at all these things, you can see what is first of B. First of B will be calculated using one additional rule. So don't get confused. Okay. So first of B will be calculated using some rule here. Okay. B and epsilon, right? But since it contains epsilon, you'll have to move further and continue. So for first of B will be ABD, and then we take it as follow of D. Okay. Follow of B is last symbol. So it will be taking a circular linked list, so it's dollar. Okay. And we update this follow of D. Okay. In this way, we continue further. So everywhere you get a symbol, you will have to compute for that symbol the follow. Okay. So if I take C, I will have to compute follow of C is first of D equal to first of D epsilon, and first rule continues as long as possible. So very important. First rule continues as long as possible. Okay. And once we compute follow, then we can basically calculate the parsing table. Okay, so parsing table calculation, let me show one small example so that it can be quickly carried out. Okay, so here it is, this is a simple example to understand the parsing table. So when we are constructing the parsing table, you will have to take every rule, and for every rule, you'll have to calculate the first of right hand side. So if I take S derives to ABDH, first of ABDH will be A, and we will write S and A, and we'll write the production S derives to ABDH. Okay. Similarly, if I take next rule, B derives to BC, CB dash, again, first of CB dash will be calculated, and B and C will be the concept. So when to use this epsilon? So if I take epsilon, okay, so first of BB will be there, but epsilon will use the follow information. Okay, so B dash derives to epsilon. First of B dash will be epsilon, and since it contains epsilon, then take the follow of B dash. Follow of B dash is GFH. So when to use follow, is it clear in the parsing table? When to use follow? Anybody? So we have calculated first follow. We will use every rule, and we will take the follow only when we see the epsilon. Okay. So epsilon rule will be added for all the symbols in the follow. So look at this here. Follow of B dash is GFH. Okay. And for GFH, you will add this B derives to epsilon. Okay. So sorry, this will be B dash derives to epsilon, not B. Okay. B dash. And if I take another rule, D tends to EF. So first of EF is G epsilon. Since it contains epsilon, continue finding. So now you have three terminals here, G, F, and epsilon. Okay. So GF epsilon will be there. Okay. And here also it is not D derives to epsilon. So GF epsilon for G, it will be no problem, D derives to EF. For F, it will be no problem, D derives to EF. But for epsilon, take follow of D. What is follow of D? It is H. Okay. And then in H, you write D derives to EF. Okay. Why D derives to EF coming in H? Because there is epsilon in EF, okay, first of EF, okay, that cannot be removed. So wherever there is epsilon, you will have to take the follow of that particular non-terminal, okay. Same, like if you say, what about E derives to G? No problem. But if I take E derives to epsilon, FH is the follow. So there you write E derives to epsilon and E derives to epsilon. Similarly for F also, F derives to small f, no problem. But again, F derives to epsilon, it will create H. So in this way, there is no multiple entries in the parsing table, and the grammar will be treated as LL1. So this way you can easily construct the LL1 parsing table. You have to understand why this, okay, and why all these productions are coming here. Everybody understood why B dash derives to epsilon is added in these three places, why D derives to EF is added. You cannot add any rule which is not given in the grammar in the table. So if I add here D derives to epsilon, it is not correct because D never reduces to epsilon. D reduces to what? EF. So for H, it is reduced. Okay. Everybody understood how we constructed the parsing table, or there is still some questions on this?
No, sir.
Okay. So what I will do is I will share this doc file with you all. I will share it with one of the person whose mail address is there with me. I think Sanket Bhoyer mail address is there with me. So he can share it with you all. I will also share it with your professor, and they can share this material with you. Okay. So I think we can stop here today, and probably on next Friday we will continue. Again, we'll meet next week on Friday, Saturday, Sunday. Okay. So thank you very much for joining. You can unmute and speak if you have any feedback or if you want to discuss anything with me. Please unmute and talk. Not an issue. You can speak in Hindi, English, whatever language you are comfortable, so that I can address your queries. So please do the needful. Thank you.